All right, everybody, we are back with some more polynomials. In this lesson, we will talk about adding, subtracting, and multiplying polynomials. So, first of all, before we do adding and subtracting here, let's talk about what like terms are. You've learned about this before, but what makes terms like? Well, part of what makes terms like is they have the same variable. So most of these have an x in them. There's one that has y. There's a couple that are just constants. But there's something else other than just the variable. They have to have the same exponent on that variable. So, for example, x to the third is like negative 7x to the third. And 4x is like negative x. They both have an exponent of 1, right? I don't write it down, but they have an exponent of 1. Also, constants. All constants are like terms. So we have this negative 9 here. That is like 100. And do we have any other like terms here? We got a 4. Are there any other with an exponent of 4? Nope. With 8? Nope. With 5? Ooh, this one has an exponent of 5, but these are not like because they have different variables. That exponent of 5 is on y here, on x here. Ooh, these are also like terms, the x to the 12th and the negative 7x to the 12th. So I just like to draw similar shapes around the like terms here, but you can show that however you want. Use different colors. Okay, yeah, so what makes terms like? The terms, all right, so that's what makes terms like. Need to know that. Well, when we go to add and subtract polynomials, you can only add or subtract like terms. You've done this before, but now we're just going to see higher degree polynomials than perhaps you've seen in the past. So yeah, we have 7x squared minus 4x and 7x squared minus 2x. So we need to combine like terms. You can pretty much just ignore the parentheses. If you want to rewrite it without the parentheses, that's fine, but you don't have to do this step. And now we just combine like terms. We got 7x squared here and another 7x squared here. Here we have negative 4x and negative 2x. You can draw the shapes around them like that if it helps. And you just add their coefficients together. 7x squared plus 7x squared gives us 14x squared. You do not add the exponents. You have the same exponent on the result term. And then negative 4x plus negative 2x is negative 6x. All right, let's do one more, and then I'm going to have you guys try a couple. So number 2, we have, let me go ahead and rewrite this without the parentheses. Sometimes those just seem to get in the way. You don't have to do this step, but it might be helpful. And then we will, let's see, we got 3n squared here. Oh, that's like the 2n squared over here. And we have negative 5n cubed. That's like the negative 8n cubed here. And then these are alike. Notice when I'm drawing my shapes around these, I'm including the sign in front. Right? This is a negative 8n cubed, not positive. All right, so 3n squared plus 2n squared, that would be 5n squared. I kind of like to cross them off as I go, especially when there's a lot of terms to add. Negative 5n to the third plus negative 8n to the third, that's going to be negative 13n to the third. And then we have negative n plus 7n, that's going to be positive 6n, right? This is like negative 1n plus 7. And that's going to be 6n. Now, one thing we do need to do, even though the directions don't say this, we should put this in standard form, which means the highest, the terms with the highest exponents should go first. So negative 13n to the third should go first, and then this positive 5n squared, and then the 6n. So always do that, even if the directions don't say so. So there's our answer there. All right, go ahead and pause this video and do numbers 3 and 4, and we'll come back with the answers. Okay, we're back. Here are my answers. I took a couple shortcuts on these. If you did them in longer ways, that's fine too, but just a couple of shortcuts that I'll share with you. On this one, when I went from this step to this step, I went ahead and just added the ones with the highest exponents first. That way I got that, I got it in standard form right from here to here. I didn't have to do that additional step that I had to do in number 2. So I added these first. I got -1 into the 5th, which you don't have to write the 1, but you have to write the negative. And then this 4 into the 4th had no term that was like it, so it just kind of comes along for the ride. And then so I did that one next because that was the next highest exponent, the term with the next highest exponent. And then of course I combined those two for that. On this one over here, I decided to take a super shortcut, and I just did my circling and combining right from here. Now be careful with this shortcut. This only works with addition. When we get to subtraction, you cannot do this shortcut. So be careful with shortcuts if you use them. When in doubt, take the long way. All right, let's subtract some polynomials. Number 5. So a couple different ways we can handle this. We could go 2 minus 7 and get -5, and then -4x to the 4th minus 8x to the 4th, which would be -12x to the 4th, and then I'd want to rearrange that in standard form. So there we go. Now, if that was, that you got to be careful, that was a bit of a shortcut, and that gets a little tricky once we get to like number 6 here. If you subtract a -6n, that's like adding 6n. So if you're not comfortable with that, you can always think of this as if there's a minus in front of parentheses, like you're distributing -1, and then rewrite the expression without the parentheses like this. So -1 times 7 is -7, -1 times 8x to the 4th is -8x to the 4th, and then you just do what you did up above with the adding the following the polynomials. So boom, boom, those go together for -5, boom, boom, those go together for -12x to the 4th. All right, I'm going to do that the next one this way, kind of going the long way, because I notice a lot of people making errors with that shortcut. Okay, so I'm going to put a -1 in front here and distribute it in and rewrite this. Now this first set of parentheses doesn't change. There's no sign in front of that set of parentheses, right? But there is. It's like this minus here changes the sign of everything on the inside of the set of parentheses. That's what multiplying by -1 does, right? So we end up with that, and then I'll go ahead and circle or draw shapes around my like terms. Okay, and then I'm going to go ahead and add these first since they have the highest exponent. And then I have -6n to the 4th that has the second highest exponent, and then these have an exponent of 1, so they'll go last. All right, you guys do the next two. All right, we're back again. So my answer for number 7, I got 7k to the 4th minus 7k squared plus 2k. So you can see what I did here. I rewrote it after I multiplied by -1, got these, circled my like terms or boxed them, and then combined like terms for my answer. Likewise on number 8. All right, let's multiply some polynomials. So this is kind of like FOIL. This actually is FOIL on number 9. It gets a little bit different on number 10. Basically, when you multiply polynomials, each term within each set of parentheses has to be multiplied by each term in the other set of parentheses. There's a couple different ways I'm going to show you how to do this. I'm going to do 9 and 10 a little differently. 9, I'm just going to use FOIL or distribution. So I'm going to take the first terms in each set of binomials, in each set of parentheses, and let's see, we'll get 7 times 5 is 35. V squared times v to the third is v to the fifth. Here's where you do add the exponents. When you multiply variables together, you add their exponents. This means like there's a total 5 v's being multiplied. All right, and then 7v times negative v, well, that would be, you can put a 1 here if that helps. 7 times negative 1 is negative 7. V squared times v to the first, right, becomes v to the third. Add those exponents. And so those were the outer terms. Now we're going to do the inner terms. So negative 6 times 5 is negative 30, and that v to the third just comes along. And then negative 6 times negative v, or negative 1v, you get positive 6, and that v comes along. You want to see if you can combine any like terms. That's not always going to happen here with these polynomials like it did in quadratics. In quadratics, usually there was always those two middle terms that combined. That's not always going to happen here. It does, though, on number 9. These are like terms, so we'll go ahead and combine those together. And we want to make sure our answer is in standard form also, which it already is here. We don't have to do any rearranging. So there we go. There is our simplified polynomial there. I'm going to show number 10 a different way. You could do 10 a similar way, going 3r times this, and then 3r times that, 3r times that, and then negative 4 times this, times that, times this. That's fine. I'm going to show you a more visual way to do it. So I have 2 terms times 3 terms. So I made my box here 2 by 3. The dimensions are 2 by 3. So what you can do is put your 2-term polynomial here, just split up the terms, and then r cubed 5r 5. And now it's just like a little multiplication chart that you fill out. You multiply, r cubed by 3r, and you put that in here. So let's do that. It doesn't really matter what order you go in. R cubed times 3r, that's going to be 3r to the 4th, right? Because this is like r to the first times r to the third. You add the exponents. R to the third times negative 4, well, you just put them together, right? Just write them next to each other. 5r times 3r, 5 times 3 is 15, r times r is r squared. You're adding the exponents of 1. 1 plus 1 is 2, of course. 5 times 3r is 15r. 5 times negative 4 is negative 20, and then this r comes along for the ride. 5 times negative 4 is negative 20. Then what you could do is write all this out. I personally like to combine like terms right from here. These are all just like individual terms in an expression, like 3r to the 4th minus 4r cubed plus 15r squared minus 20r, etc. So to save a little space here, I notice that these are like terms. Those are the only 2 like terms, so I'm going to combine those when I write this out. And also, if the original expression, if each piece was in standard form, see how this was in standard form, this is in standard form, the highest exponents come first in each piece of the expression here. The result should be in standard form, which I can see it is if I go left to right, top to bottom. So 3r to the 4th minus 4r cubed plus, because it's positive, 15r squared. And then these combine to give me negative 5r, right? Adding those up, we're adding them, so negative 20 plus 15 is negative 5, and then we have a minus 20 at the end. There we go. All right, on the back, there are 2 for you guys to try. So on the back side here, go ahead and do numbers 11 and 12, and we'll check back after you finish. Here is the answer for number 11. You had to FOIL it out, or you could have also drawn a 2 by 2 box for this one and multiplied it out that way. Either way, this should be your final answer. There were no like terms on this one, like on number 9. So you couldn't combine anything, but you did have to, depending on how you did it, if you did it the normal FOIL order, you had to switch a couple terms around to get it in standard form. So sometimes this is called descending order of exponents. We have 5, 4, 2, and then 1 for the exponents, right? All right, and then number 12, I did that with the box, and this is what I got here. All right, that is it for adding, subtracting, and multiplying polynomials.